All right, let's go ahead and pray. Heavenly Father, just again, thank you for the day. Thank you for the blessings you've given us. Just be with the ones that are having to quarantine and distance learn. I just pray you may help them, Lord, stay up to date, stay focused. Just God and lead everything we do. In Jesus' name, amen. All right, questions on your homework? We didn't have any homework last night. All right, so let's look at derivatives or special derivatives. Special derivatives. 3.9, yes. All right, the quiz 3.7 and 3.8 will not be tomorrow. That will be probably next Tuesday. We're going to add 3.9 to that. 3.7, 3.8, 3.9. It's sort of going to be in between of a test and a quiz because we're starting to get to the point where a lot of our problems are kind of lengthy. So for me to test you on what I need to, all right, it's going to be more like every 2 lessons. And it's going to be named a quiz, but it'll sort of be like a test, sort of. But it won't be as many points as a test, but it will be a little bit more points than a quiz. So that's, yeah. So basically, if you want to call it that, a quest. All right. So we got 4 special derivatives we want to look at here to be able to do this. The first one is dy dx of e to the x. dy dx of e to the x. So if we look at this and use our limit rule, the limit as h approaches 0 of e to the x plus h minus e to the x all over h. And we look at this, e to the x plus h, well that is going to be the same thing as limit as x approaches 0 of e to the x times e to the h minus e to the x over h. To help simplify this, we're going to factor out the e to the x. That looks like an L, but it's an e. The limit as h approaches 0 of e to the x times e to the h minus 1 over h. And we're going to simplify this. The limit as h approaches 0 of e to the x times the limit as h approaches 0 of e to the h minus 1 over h. Well, here when we look at this, e to the h minus 1. Well, as h approaches 0, where is e approaching?
Which one? Sorry.
As e to the h, or h approaches 0, what is, well, let me go back here. Back in the beginning, they say that this expression here, if we were to graph this, we would find out that it is going to be 1. This equals 1. Does anybody have their calculator right handy? Go ahead and graph e to the x minus 1 over x. That's what you want to graph. All right. Let me change the window here a little bit. -5, 2, 5, 2, -5, 2, 5. So if we see the graph, there's e to the x minus 1 over x. All right, let me put it in here. All right, and where, as I get closer to 0, where is the graph going? As we get closer and closer to 0, what's the limit as I get closer to 0? It's getting closer to 1. All right, so that expression is 1. So that's how they go ahead and prove this, because the limit as h approaches 0 of e to the x is e to the x times 1, which equals e to the x. So the derivative of e to the x is a tough one to remember. It's just e to the x. Okay? And we could also see this, that if we graphed e to the x, and then we graph the derivative of e to the x, we would see that they're the same graph on your calculators. That's something you could do as well, if you wanted to. Graph e to the x, and then graph and y1, and graph the derivative of e to the x and y2, you'll find out that they kind of lay on top of each other. So e to the x, graph of e to the x, derivative of e to the x is e to the x. And you don't necessarily have to know the process. I just did that for FYI for you to see that. All right, derivative of a to the x. All right. So this is how they do this. Let's say y equals a to the x. I don't want to do this here. Let's take the logarithm on both sides. Let's change this to y equals e to the x. No, not x, a. Ln x. What do I do? That is the same thing as e to the a. All right, have a brain freeze here. Get backwards. E to the x. Ln a. Because this is the same thing as e to the ln a to the x. All right, there we go. That's what I want to do. Everybody agree? Power to a power and multiply. All right, so this is just x ln a. E to the ln a is a to the x. So we didn't really change anything. It's still the same function. Okay? So that's what I wanted to show you. I wanted to get to that point. Now I'm going to take the derivative of this function here. Right? The derivative of this function here.
Oh, we use the chain rule?
We're going to change, correct? Use the chain rule.
Okay.
So the chain rule is derivative of the function, which is this, correct? Times the derivative of the composite. The derivative of x ln a. Now remember, ln a is a constant. It's like a number. So what is the derivative of ln a x?
ln a.
ln a. So now I can change this back. E to the x to ln a is a to the x ln a. So let's change this from a to the x to a to the u. The derivative of a to the u is going to be a to the u ln a. So if I wanted to take the derivative of 5 to the x, my derivative would be 5 to the x ln 5. If I wanted to take the derivative of 2 to the 3x, my derivative is going to be 2 to the 3x times 3 ln 2. Because remember, we have a composition here, so we use our u substitution. So 2 to the u, we say y equals 2 to the u, and u equals 3x. Y prime equals 2 to the u ln 2 times 3. Okay. So here's your derivative here. Here's your derivative here. We'll look at the other two derivatives and we're going to do a lot of problems. Next derivative. dy over dx of ln x. This one's a pretty cool one. We say y equals ln x. To take the derivative here, it would be better to change to an exponential. So we're going to change this to e to the y equals x. Take the derivative, implicit differentiation, e to the y is e to the y dy equals dx.
But wouldn't the derivative of EY be EY ln E? Or, oh no, because that would equal 1.
Right? E to the y just like this here. E to the x equals e to the x. So e to the y equals e to the y. Okay? We divide dy over dx equals 1 over e to the y. What does e to the y equal? Now what does e to y equal? X.
Also, it's 1 over x.
1 over x. So if this was ln u, this is equal to 1 over u du. Each one of these should have a du by it. This was e to the u. E to u to du. That's a fairly easy one too. If my y equals ln to the 5x, take the derivative of my function, ln 5x is 1 over 5x times the derivative of my composite, which is 5, which equals 1 over x.
So will the derivative for any logarithm
Pretty much.
always be 1 over x?
Pretty close. Not exactly. Because what if we had y equals ln to the x squared? Well, the derivative here is 1 over x squared times
2x.
2x. So what do I have?
2x.
2 over x. So we're close, but not exactly. Alright, the first and the third ones are good ones, those are easy ones. Those are neat ones. The last one's a little bit difficult. dy over dx of log base a. Alright, so if we look at this one, y equals log base a of u. Let's see if I can do this right. I mess it up every year. Let's see if I can do this right here. Alright, so I change back to an exponential. My base is a, my exponent is y equals u. And again, I'm showing these how they get these, but you don't have to do these every time, because you're just going to use the pattern and the memorization to do it.
Will this be in the homework though, like proving?
Proving? Probably not.
Okay.
Alright? Derivative of a to the y.
That's a to the y.
A to the y. ln a dy equals du. So dy equals 1 over a to the y ln a du. What does a to y equal? Equals u, right?
Yeah.
This way. So that's going to be 1 over u ln a du. So along with your derivatives of your inverse trig functions, you have these to memorize as well. Turn to page 178. Page 178. Let's look at number 2. Number 2. Y equals e to the 2x. Y equals e to the 2x. So which one are we going to use? 1, 2, 3, or 4?
1.
Number 1, which says is e to the u du. So we're going to have, what's my e to the u is?
E 2x.
2x times
2.
2. Number 4. E to the negative 5x. You use the first one. So Grace, what do we get?
Negative 5 times e to the 5, negative 5x.
Excellent. Good job. All right. Let's look at number 8. Y equals x squared e to the x minus x e to the x. Alright, we can do this one or two ways. We can leave it as a sum with two product rules, or we could change it to one product rule by taking out the e to the x. Oops. Alright, product rule says, first, times the derivative of the second, plus the second, times the derivative of the first. Everybody agree? Simplify. I'm gonna take out, let's do this. I'm gonna take out the e to the x again. I'm left with 2x minus 1 plus x squared minus x. Simplify e to the x times x squared plus x minus 1. And there's my derivative. And I can multiply that out too, or I can just leave it like that. So number 12, 9 to the negative x. Which one am I going to use?
Do the A to the U.
Second one. So y prime is going to equal a to the u, which is
So 9 to the negative x.
times ln a
So 9,
times du.
which is -1.
And just rearrange that so it's proper. Negative 9, x to the negative x, ln, that should be 9. 9. Let's look at number 20. X ln x minus x, x ln x minus x. All right, Noah. X ln x, derivative.
When you do the product rule,
Okay,
so first x times 1 over x plus ln x. That's it.
times 1, right?
Yeah, times 1.
Continue.
Minus 1.
X times 1 over x.
1. ln x.
Okay. Let's look at number. Look at number 42. Y equals log base 10 of the square root of x plus 1. All right, which one will we use here? Okay,
Number 4.
number 4. So what do we have?
That would be 1 over 1/2 times x plus 1 to the negative 1/2.
Do that again?
Cause it'll be times the square, the derivative of u, right? Or just u?
Well, we got 1 over u ln a
Then it'll be the square root of x plus 1
times
times ln 10.
10 times Now the derivative of u,
1/2 x plus 1 to the power of negative 1/2.
alright, so let's simplify this. So the 1/2, when I times that, that's gonna go where? The 2 is gonna go where?
To the bottom.
To the bottom. X plus 1 to the negative 1/2 takes a square root to the bottom, correct?
Okay.
So when I take the square root of x plus 1 times the square root of x plus 1, I get?
That will be x plus 1.
X plus 1 times ln 10. So therefore I'm gonna get 1 over 2x plus 2. Make sure I put it in parentheses. ln 10. Which would be my answer. Okay, so that's how we're using those derivatives to be able to do some of the things that we're doing here. Any questions? All right, we are doing page 178. We are doing numbers 1 through 53. Every other odd.
No math XL?
No math XL tonight. 1 through 53, every other odd.
Do you still want us to do the evens from the last lesson, which would be due tomorrow?
The 4 through 28.
Yes, and then I usually
All right, the 4 through 28. What was the 4? That would be bonus if you want the bonus, if you want to complete it. And the same with 2 through 28. Every other even, that would be bonus if you want to complete it. So those are optional there. But this would be required here. Okay?